Complete destruction of viruses was obtained at pH 11 and contact time 5 hours and 10 minutes. You can imagine if you use this excess lime for your disinfection, the water need to be at pH 11. So before it is get distributed or it is get to be used by the consumers, you need to lower the pH again. And also the contact time also is very long, 5 hours and 10 minutes. Okay. Okay, the silver treatment is also metal ion treatment just now. This one, metal ions. Silver, when immersed in water, has inhibiting effect on bacterial life. As silver is costly, this method can be used in small scale. So when you put the silver, the live bacteria become dead, and it will the silver ion and the bacteria will become precipitate, will become solids, so that they are removed from the water, but you are putting the silver, and silver is also very expensive. These are types of treatment. And ultraviolet, just now, irradiation can disinfect both water and wastewater. However, its use in drinking water disinfection is limited to small installation because of the disadvantage that we have discussed just now, such as about shapes, because it does not produce residual, meaning that once you this is the same like what you did for your pH using lime, the lime treatment. Because you don't have any residual, meaning that after you treat using ultraviolet, then you need to use the treated water right away. So you cannot wait, because they don't produce any residual. So in wastewater treatment, and when compared to chlorination and ozonation, UV was found more effective, more economical. Okay, so if UV irradiation is getting prominence. Okay, so this is based on case-to-case basis, because you cannot say that UV irradiation is always useful and can be applied at any situation. Okay, ozonation is also this chemical treatment. General characteristics of ozone: it's a powerful oxidant, more powerful than hypochlorous acid, which is from the chlorination. Unstable in aqueous solution, has a half of 20 to 30 minutes in distilled water. Widely used in drinking water treatment, is produced on site and cannot be stored site. Okay, so that's why it is expensive, because the radiation of the ozonation need to be carried out at the site, and also you don't have any residual, meaning that you need to produce the ozone using the ozone generator at site, and then you use the ozone for the treatment. And the treated water must be used at the site too. You cannot distribute using your piping network to a household which is quite far from the treatment plant. Okay, and also you can also have potassium permanganate. This is a chemical oxidant also, commonly used in rural areas, used for purification of open water supplies. Potassium permanganate is dissolved in bucket and added in a well water. Water should not be used during first 48 hours after potassium permanganate addition. This is when you use well water. In some states, they are using well water. You just want to make sure that it is free of pathogens, then you can use potassium permanganate. Okay. Suitability of the disinfectant. What type of disinfectant that is suitable for your treatment? So you need to know what are the criteria when you want to choose the type of disinfectant treatment that you want for your water supply system. Disinfectant shall be effective in killing the microorganisms, should be cheap and readily available. Okay, this is very important. Should be safe to handle and easy to apply. It should not make water toxic in nature, like when you are putting metal ion or chemicals, you have to be very careful. It should have ability to persist in residual state, meaning that the disinfectant that you are putting in your water supply need to be there quite a long time whenever you need the time for distribution to household, and also when the time comes for the water to be used. So conventional water purification system. So you need this raw water supply. So this is the receiving well, coagulation, sedimentation, filtration, and disinfection. When you distribute to homes, so you have to disinfect here. Then you also have to make sure that some of the disinfectant is still in your water supply before it stays there until the water reaches the household. That's why it should have ability to persist in residual states. Okay, some of the disinfectant like ozone is very good. Calcium permanganate is also very good. But if you want to use the water at the same site when you treat the water, then it's okay. But if you need time for the distribution, then you have to think about something else that will produce the disinfectant in the residual state. Okay, so this is after you look at the many types of disinfection system, you will then realize that chlorination is the best. Chlorination is the best. Why? Because the most important oxidant used for disinfection is chlorine. Chlorine is one of the halogens. At a normal temperature and pressure, chlorine is yellow-green gas. It is heavier than air and can be liquefied. So chlorine is rather soluble in water. Solubility decrease at rising temperature. Okay. You can see here, these are the characteristics of chlorine. So why chlorine is chosen? Chlorine is one of the most widely used disinfectant, and it is effective at low concentration, form residual if applied in sufficient dosages, very effective for the deactivation of pathogenic microorganisms. So chlorine is a strong oxidizing agent. It oxidizes enzymes of microbial cells that are necessary for metabolic processes, thus inactivating the microbial cells. But in terms of actually the strength of the oxidizing agent, ozone is much more stronger than chlorine, but it is very difficult because you need it's quite expensive treatment, and they don't produce residual. Chlorine can be easily applied, measures and control. It is relatively cheap. However, we only started using it as disinfectant on a wider scale in the 1973 after Louis Pasteur discovered that microorganisms spread certain diseases. Okay, so chlorine has played an important role in lengthening the life expectancy of humans. This is when maybe they talk about this based on some data. But of course, there are many other factors that improve the life expectancy of humans. But since you know that the component of human body at the 80% based on due to water. So if you have a very good water supply, then of course that the benefits this factor of water supply actually really affect the life expectancy of humans. Okay. disinfection efficiency depends on the type and concentration of the microorganisms, type and dosage of the disinfectant based on what are the types that you choose, contact time, clarity of water, presence of other chlorine consuming compounds, temperature, and pH. Okay. So chlorination reaction. You can see here that chlorine gas reacts with water to form, this is chlorine gas react with water to form hypochlorous acid and hypochloric acid. Hypochlorous and hypochloric acid. Okay, so this hypochlorous acid will then dissociate to H plus and chloride, chloride, this OCl minus. So the dissociation of the HOCl is a function of pH. So hypochlorous acid is 80% is 80 times more effective disinfectant than hypochlorite ions. Yeah, this is meaning that this chlorination, the chlorine gas, after they form hypochlorous acid and then hypochlorite ions. But this is the form that it is very effective for disinfectant process compared to the hypochlorite ions. Chlorine will appear in water in three forms: the elemental chlorine, the hypochlorous acid, and also the hypochlorite ions. Okay, so this is the strongest, oxidant, the disinfectant. This is the hypochlorous acid. Okay. Okay, you can see here what is the best pH. This is the percentage of hypochlorous, because actually for disinfectant you want as much as possible that the form that the available form is hypochlorous acid, because you know that it is 80 times more effective disinfectant. So we want to know what is the pH value that favor the formation of this hypochlorous acid. For pH less than 5, only elemental of molecular chlorine is present. 5 to 10, both hypochlorous acid and hypochlorite ion present. Greater than 10, only hypochlorite ions are present. So meaning that it's good to maintain the pH within this range, because you want to have hypochlorous acid as much as possible. So below pH 7, concentration of hypochlorous acid is more. pH of water should be less than 7 to prevent ionization of hypochlorous acid, because ionization of hypochlorous acid will produce hypochlorite ion, which is not that effective if you compare with hypochlorous acid. Okay. Okay, so what is chlorine demand? Chlorine demand is when chlorine is added in water, it reacts with organic and inorganic impurities. So we will then see the figure. The amount of chlorine utilized for this is known as chlorine demand. The remaining chlorine will appear as available residual chlorine, which serve as disinfectant to kill the pathogens. So as summary, what is dosage, demand, and residual? Dosage is the amount of chlorine added. How much amount do you add to the water supply system? Demand is the amount of chlorine needed to oxidize materials. So the reaction. Residual is the amount of chlorine remaining after oxidation. So you have to make sure that after disinfection, you still get residual chlorine in your water system. So residual chlorine is the dosage that you provide minus the demand to oxidize other materials. Okay, so this is the residual chlorine. Okay. Okay, this is the formula for you to calculate dosage of chlorine. The chlorine dose required depends on two considerations. The chlorine demand and the desired chlorine residual. Okay, maybe sometimes you need 3 to maybe 6 or 8 milligram per liter after the treatment. You must have this still chlorine residual in your water supply. This is to ensure that when you distribute your treated water, this disinfectant matter will still be there. So in case during the piping to the household, you got these organic contaminants, you got these pathogen microorganisms, the chlorine residual will be able to disinfect these microorganisms. That's why it is for you to determine actually in the guidelines it is stated what is the residual needed for your water supply system. So the dose that you provide to the disinfection process is based on demand and also the residual. So the dose is feed rate divided by flow. This is the feed rate, the dose. Example, a water treatment plant has used 150.6 kilogram of chlorine during the past 24 hours. So meaning that 150.6 kilogram of chlorine per day. The flow for the same period was 19.95 million liter per day, MLD, million liter per day. What is the dose of chlorine applied to the water in milligram per liter? So based on this formula, the dose is feed rate over flow. So you know the feed rate, which is 19. The feed rate is 150.6 kilogram per day divided by the flow, which is 19.95 million liter per day. Okay, so this is the dose of chlorine that you have applied in your water treatment. Okay. Okay, chlorine can be used as disinfectant of the following forms. So even though you have chlorine, but you can still choose what type of materials, what types of forms that you want your disinfection using chlorine in your water treatment. You can use gaseous form of chlorine, which is, you can see this, this is yellowish gas, and you got this tank of chlorine. So this is good. This is good way of treating disinfecting your water treatment plant, but you have to be very careful, and you must have expert person, these treatment operators, not operators. I think technician need to be there to take care of the chlorine gas that you store in your water treatment plant site. So you can also use bleaching solution, sodium hydroxide. So this bleach consists of chlorine gas dissolved in an alkali solution, such as sodium hydroxide. So the chlorine reacts with sodium hydroxide to form sodium hypochlorite. So this is, you put this in the form of solution, the bleach, by putting this chlorine and also sodium hydroxide. So you get sodium hypochlorite. So this is in the liquid form. So meaning that it is easier to handle. Anything that is in liquid form is easier to handle compared to if you have this in the gaseous form. Okay, and then the bleaching powder, this is produced by directing chlorine through calcium hydroxide. The benefit of bleaching powder is that it is a solid. So of course, if you have solid, it's easier to handle, easier to store, easier to apply. Compared if you have this liquid or if you have in the gaseous form. Okay, so the bleaching powder just now you have here chlorine and calcium hydroxide. You have this bleaching powder. So the available chlorine is only 20 to 40%, because you have combined this calcium hydroxide with this hypochlorous acid. When it is added in water, following reaction take place, calcium hydrochloride plus water, you get hypochlorous acid and calcium hydroxide. So hypochlorous acid acts as disinfectant. As it contains 20 to 40% chlorine, it requires higher transportation costs and space for storing, because these you need to use lots of bleaching powder because the concentration is very low. Therefore, use in small scale like rural water supply scheme. So you cannot use in a very big treatment plant because you need to have, it's not economical because you need to use a lot of this powder, because it is not concentrated. Okay. And like chloramines, you can also have chloramines. Chloramines, the free chlorine can react with compounds such as ammonia, proteins, amino acids, and phenols that may be present in water to form chloramines and chloroderivatives, which constitute as combined chlorine. You can also call combined chlorine if in your water supply, you already have this ammonia, protein, ammonia acids, and phenols, or you may add to this treatment system these materials because you want to use chloramine as your source of disinfection. Combined chlorine possesses disinfection properties. So when you have ammonia, you react with hypochlorous acid, you will get monochloramine. Monochloramine. And if this monochloramine will then react again with the hypochlorous acid, you get dichloramine. And this dichloramine and then react again with 3 moles of hypochlorous acid, you will get nitrogen trichloride. So total chlorine can be in terms of free chlorine, or you can use combined chlorine. Combined chlorine is when you add ammonia to chloramine. Of course, there are certain advantages of using this chloramine that we will discuss later. Why don't you just use chlorine? Why do you need to use combined chlorine? There must be something why you use this chloramine. So combined chlorine can be in terms of inorganic chloramine or organic chloramine. So you don't have to detail out or memorize all these the terms for this chloramine, but I want you to understand that you can use free chlorine like what you did from this previous slide, and you can use also combined chlorine by reacting the hypochlorous acid with ammonia. Okay. So you can see that depends on the pH range, the types of chloramine that will be formed. If the pH is less than 4.4, you will get the trichloramine only. If the pH, this is the distribution diagram for chloramine species with pH. So this is explained in the table here. If 4.4 to 5, you will get dichloramine only. If 5 to 8, both mono and dichloramine. If greater than 8.5, you will get only monochloramine. So what are the advantages of using this chloramine? They are more effective than chlorine alone, prevents taste and odor, because if you have chlorine, in your water because you need to have residual chlorine, right? So you will you can taste the chlorine, and it is not dangerous, but it is not acceptable for you to drink water with chlorine taste. So you use chloramine. Water treated with chloramine causes less irritation of eyes and odors. No danger of overdose, because if chlorine you overdose, you will get something else that we will discuss later. Less chlorine is required because you have already combined the chlorine with ammonia. Okay, free chlorine, generally applied in gaseous form or liquid form, 2.48 times heavier than air and 1.44 times heavier than water. It is strong oxidant, forms residual. Byproducts are formed, example, trihalomethane. So this trihalomethane is a very toxic, so we have to be very careful when you use free chlorine in disinfecting your water system. So in your water treatment plant design, if you use disinfection and you choose, you need to specify the type of disinfectant that you want to use. And if you use chlorination, you also need to specify whether you are using the free chlorine or you are using the sodium hydroxide combination of chlorine, or you want to use chloramine. You have to specify all those, and then you have to also do a bit discussion in the safety, even the sustainability of the unit operation, especially in terms of safety at the site. Okay, byproducts are formed. Example, trihalomethane works under specific pH. So this is where you have this input the meter to your water treatment plant if you use free chlorine. This is the regulator, and this is the chlorine gas tank. So it needs to be controlled properly. Okay, so what is trihalomethane? Trihalomethane is something that is discussed a lot nowadays, especially on the sustainability of water supply system to make sure that it is safe. Trihalomethane are a class of chemical compounds derived from methane in which 3 of the 4 H atoms have been replaced by halogens. Possibilities in drinking water include chloroform and bromoform, and also you can also have chloroform, meaning that all the DH in the compound in the structure has been replaced with halogen of chlorine elements. So what are the health effects of trihalomethane? If you have this chloroform, the adverse effect is cancer, liver, kidney, and adversely affect the process of reproduction. If you have a bromoform, the kidney affects the nervous system, liver, kidney, and reproduction. If you have dichlorobromoform, cancer, liver, kidney, and affects the process of reproduction. And CHBR2, cancer, nervous system, liver, and kidney. So you have to be very careful with this chlorination. Okay, these are the byproducts that we want to avoid when we have this chlorine being used as disinfectant. Okay, chlorine dioxide. Chlorine dioxide is created by mixing solutions of sodium chloride and chlorine. Okay, you add sodium chloride and chlorine, you will get chlorine dioxide. So the advantages of chlorine dioxide are it is a strong bactericides and virucides over a wide pH range, meaning that you can treat you can remove bacteria and you can remove virus over a wide range using this chlorine dioxide. it forms a slight residual in the distribution system. This is what we want because we want to have slight residual. It does not react with nitrogen to form chloramines. It does not react with organic matter to form trihalomethanes. So let's say if you suspect that you have organic matter in your water, the water that you are going to disinfect, then you use chlorine dioxide, because by using chlorine dioxide, it will not react with the organic matter. Otherwise, if you just use chlorine, it will form trihalomethane, which is very dangerous. You can see it from the table just now. It's about cancer. It's about cancer on the liver, on the this kidney, your production system. So it's very dangerous. The disadvantages of chlorine dioxide are its high cost and its tendency to create chlorine and chloride, which are also potential toxins. Chlorine dioxide is used for taste and odor control as well as disinfection. Okay, so that you need to also control the dose, because it will also create other potential toxin like chlorine and chloride. Okay. Okay. How chlorine kills or deactivates? So chlorine disinfects water through two mechanisms. You oxidize power of free oxygen and chlorine substitution reaction. So the oxidizing powers, you can see here that hypochlorous acid to hydrochloric acid and O, oxygen. Free oxygen is produced by the breakdown of chlorine compound in water. Okay, see, oxygen attacks the lipids in cell walls of the microorganism and destroys the enzymes and structures inside the cell, which either destroys or inactivates it. It's the oxygen here that the oxidizing power, the free oxygen here, that will attack the lipids in cell wall of the pathogens or viruses that you have in water. So the chlorine will play its role to disinfect your treated water based on the oxidizing powers of the free oxygen, and also the chlorine substitution reaction. So the chlorine will also substitute whatever that you have to make sure that the microorganisms cannot live or cannot, they become inactivated. Okay. This one, actually this one I want to show this chlorine substitution. So chlorine breaks chemical bonds in enzyme molecules and replace some hydrogen atoms with chlorine. Okay, this changes the shape or destroys the molecules and make it difficult for the enzyme to function properly, because the chemical bonds have already been replaced with hypochlorite ion here. Okay. Without effective enzymes, the cell either dies or is unable to reproduce. So based on the power of oxidizing power, the free oxygen that attacks the lipid cell wall, and the replacement of chlorine to the chemical bonds in enzyme molecules, so the pathogens or the microorganisms become inactivated. Okay, so dying of bacteria is often described by the law of Chick. You have here, let's say you want to know the number of organisms at any time, you can use the law of Chick. In disinfection, often the concentration of the oxidant or disinfectant is included. So how much oxidant or disinfectant that you use will determine the number of organisms at time t. So this is all about the law of Chick. Okay. What are the forms of chlorination? you can disinfect your system based on plain chlorination, breakpoint chlorination, and super chlorination. Okay, so let's look at how each of these differs. Okay. Okay, plain chlorination is when you apply chlorine to raw water before it enters into distribution system. Sometimes added to reservoirs to check growth of weeds, organic matter, algae, etc. The process of addition of chlorine only when the surface water with no other treatment is required. Okay. Let's say that the water is very clean. Then before you distribute, you just want to make sure that there's no pathogen in your water, so you just use plain chlorination, meaning that it can be practiced for water with stabilities 20 to 30 NTU. So those range can be 0.5 to 1 ppm, meaning that you know that the water is very clean. You just want to ensure that the pathogen, that the water is free from the pathogens and viruses. So you put you apply the chlorine. So that is what we call plain chlorination. Just before you use, you add plain chlorination. Okay. Okay, breakpoint chlorination. What is breakpoint chlorination? Okay, this is the chlorine that you add, and this is the chlorine residual. Okay, usually we have this situation. When chlorine is added, it reacts first with reducing compounds such as ferromanganate nitrate ion, and the chlorine will be reduced to the non-effective chloride ion from 0 to point A, meaning that usually the water is not that very clean. You have other reducing compounds like ferric 2, mangan, and nitrate, and the chlorine will be reduced to the non-effective chloride ion, meaning the chlorine is used to disrupt the chlorine residual by reducing compounds. By the reducing compounds here. So it is used. When adding more chlorine, it will react with ammonia to form chloramines. And then when you have ammonia in your water, after the chlorine is used for reducing the reduced compounds, then it is used by the to react with ammonia to form chloramines. When adding more chlorine, some chloramines are oxidized to nitrogen gas, and the chlorine is reduced to the non-effective chlorine ion from B to C. Oh, actually C is here, the breakpoint. Continued addition of chlorine will produce free available chlorine at point C, and the point C is called the breakpoint. Okay. So after you use it for destruction of chlorine residual by reducing compounds, then it is used by the ammonia. So you call it combined residual. And then chloramines and chloroorganic compounds, and then some of the chloramines will be oxidized to nitrogen gas. You will get chlorine until the break point, and then from the break point you will get free and combined residual, meaning that whatever here you have the chlorine, they are free, meaning because when you treat when you disinfect your water, you need to have some free compounds. So this is where from this break point you have this free residual. Okay. Okay, and then you have plain chlorination, meaning at the like a reservoir, you just want to check, you just want to make sure without thinking of distributing the water after the treatment, meaning that you don't need to think about the residual. This is what we call plain chlorination. Or you can have this breakpoint chlorination, meaning that you have other compounds because the water is not that clean like what you have for the plain chlorination. And you can also have super chlorination. Chlorine is applied beyond breakpoint. It is done after filtration with contact time of 30 to 60 minutes. It is practiced when there is epidemics in the society. Okay, so you just want to make sure that they are properly disinfected. So you just add in more chlorine if even after you reach the break point of your chlorine supply. Okay, for the point of chlorination, where do you want to put your chlorination in your treatment plant? You can use it for pre-chlorination, meaning that chlorine is applied before treatment, especially before filtration, sometimes added before sedimentation. Reduces coagulant. The advantage is when you have pre-chlorination, it will reduce the bacterial load on filtration because bacteria, they have mass and they will provide there will be some loading to the filtration. But if you have reduced, then you will reduce the load to the filtration unit. Reduce coagulant required, control growth of algae, eliminate taste and odor. You can use it for pre-chlorination. You can also use for post-chlorination. This is what is the conventional treatment usually apply. Addition of chlorine after treatment, which means before you distribute, you put some chlorine as a disinfection treatment. Added before water enters into the distribution system. So before you distribute in the piping, sewer net, the the pipe network of your water supply, you put this chlorine for disinfection. Okay. Okay, you can also have double chlorination, application of chlorine at 2 or more points in purification process, usually added before sedimentation tank and after filtration. This is done if water is more contaminated. Okay, so you know that it is water very contaminated, especially maybe not far from that. You have septic tank, okay, because it will affect the groundwater, it will affect the water supply. Maybe you take the water from that river or your source water supply. So you can use double chlorination to make sure that all the pathogens and viruses become inactivated. Dechlorination, process of removing excess chlorine from water is known as dechlorination. Just now you know that in the residual, you just have to keep like 3 to maybe the most 8 milligram per liter of chlorine. If you have more, then it's not dangerous, but it will affect the taste and it will not be acceptable by consumers. Okay, can be achieved by aeration or using chemicals such as sodium thiosulfate, sodium bisulfate, sodium sulfide, activated carbon, and potassium permanganate. Okay. I don't stop because not much. We still have like 10 slides. Okay, I just continue. Okay, factors affecting chlorination. One of the factors is turbidity. Turbidity affects chlorination process as efficiency of disinfection process decreases if water is more turbid. Pathogens can shelter behind solid particles. So chlorine is added after removing turbidity, meaning after filtration. Usually after filtration, because if you put chlorine before the filtration, you will need to use lots of chlorine. Presence of metallic compounds like ferrum and manganese consumes more chlorine if present in water. Just now we have looked that it is it will reduce the effectiveness of chlorine dosage. So chlorine is added when ferrum and manganese are removed from water. Let's say if your water supply, you see that they have this ferrum and mangan in your characteristic of your water source, then you need to remove this ferrum and mangan before you do your disinfection process. Otherwise, it will take up a more concentration of the chlorine, and you have to provide extra than what it is needed. Okay. Ammonia compounds. Ammonia forms combined chlorine which are not so powerful disinfectant as compared to free available chlorine. Therefore, more chlorine is added so that after formation of chloramines, excess free chlorine is available for speedy disinfection. Okay, pH of water also affect the chlorination. You can have free chlorine if the pH of the system is up to 6.7. At 7, only 80%. At 8, 30%. At 9, 5% of the total free chlorine. Meaning that at higher pH, you will get less effect of chlorination. Meaning that's why for chlorination, you need to use a quite low pH. Temperature of water. Reduction in temperature decreases killing power of both free and combined available chlorine. Meaning that higher temperature is better. Time of contact, percent kill of pathogens depend upon contact of chlorine and microorganisms. So time of exposure or time of contact is needed. Usually for free chlorine, 10-minute time is required as compared to 60 minutes for combined chlorine. So to be safe, if you have this ammonia in your water, then you need 60 minutes because the time of contact is about 60 minutes for combined chlorine. Okay. Again, factors affecting chlorination, nature and concentration of bacteria and viruses. Bacteria spores are more resistant. Poliovirus is most resistant. Okay. Theory questions that you need to understand from what we have learned today. You need to be able to explain what is breakpoint chlorination. You need to be able to explain what is pre-chlorination, post-chlorination, superchlorination, and dechlorination, double or multiple chlorination. When does this occurs? Discuss factors affecting chlorination, and you need to discuss chemistry of chlorination. What is the power of this oxygen? How they attack the lipid cells? And also how this chlorine destroy the pathogenic microorganisms, the mechanisms. What is chlorine demand? Chlorine demand is the amount of chlorine required to kill bacteria, oxidize iron or other elements in the water. Free available chlorine residual is the amount of chlorine remaining in the water after the chlorine demand has been met. Contact time is the amount of time that the chlorine is present in the water. The combination of chlorine residual and contact time determines the effectiveness of the chlorination treatment. Okay. Effectivity of chlorine, for example, disinfection time of fecal pollutants with chlorinated water. If you have this E. coli 0157 bacterium, less than 1 minute, you can disinfect. But if you have hepatitis A virus, about 16 minutes, Giardia parasite, about 45 minutes, Cryptosporidium about 6 to 7 days. Okay, so it is important that you can observe this, especially like Cryptosporidium, amoeba type microorganisms. You can look under the microscope, but if you have this in your treated water and you want to use disinfection process, then you know that it will take 6 to 7 days for you to ensure that these microorganisms is removed in your water supply. So when you look at the characteristic of your water source, you have to sometimes you can see the detailed type of microorganisms. Okay, by looking at this detailed type, you know this amoeba type, they exist in your treated water, then you need to apply 6 to 7 days of disinfection. Okay. Okay. The chlorine dosing equipment should be sufficient enough, firstly, to allow not less than 30 minutes of contact time with the water before use, and secondly, to maintain chlorine residual of at least 0.3 to 0.5 gram chlorine per cubic meter after that time. Okay, 3 to 5 milligram per liter of chlorine in the residual chlorine. And you need to at least have 30 minutes, yeah. But just now when I show you, if you have things like amoeba, yeah, the chlorostridium, yeah, then you need to have your contact time at least 7 days to make sure that these types of the fecal coliforms is removed. Okay. So this is the formula. There exists a certain relation between chlorine demand and contact time. So you can use this chemical formula if you want to determine the chlorine demand based on the contact time that you have specified, or you change a bit. Chlorine demand after 1 hour and the constant, yeah, N, meaning the higher the N, the more complicated the system. For groundwater containing mainly ammonium nitrogen, the N is 0.01 to 0.05. But when you have surface water treated, N is larger, 0.1 to 0.2, then you know that it is more complicated and it is more polluted, depending on the value of N. Okay, this is a photo showing you this how you supply this gaseous chlorine, or you can use liquid chlorine. You have all this control valve. You need to have this, the suction hose, the hypochlorite tank, the metal tank, the pipe drain, everything that you need to ensure is available in your treatment site. Okay, this is the water feed. When you use the suction line, you use this. This is the solution container, the strainer, and the chemical feed pump, discharge line, and the water main. Okay. Calculation examples, how you calculate the chlorine dose. The required chlorine dose can be calculated by defining the desired residual, the volume of flow, and the chlorine demand. Okay, so example, if you want to disinfect 2,000 cubic meter per day of water, and you want to produce a chlorine residual of 0.6 milligram per liter with water having 1 milligram per liter chlorine demand. Okay, so this one is based on your test. You will be able to know what is the chlorine demand of your water. But this one, chlorine residual of 0.6 milligram per liter, maybe you just follow the guideline that you need to have chlorine residual in your water supply after you treat, before you distribute. You need to have chlorine residual, and you need to disinfect 2,000 cubic meter per day of water. So the chlorine dose rate is the flow multiplied by the 1.6 milligram per liter. The chlorine demand is 1. The chlorine residual that you need is 0.6. So the chlorine demand is 1.6 milligram per liter. So you make sure that the unit are right and correct. So you will be able to get the chlorine dosing rate is 3.2 kilogram per day. For the chlorine pump dosing rate, the commercial hypochlorite solution can contain 0.5 kilogram chlorine per liter. You buy the hypochlorite solution, and the required volume of hypochlorite solution is based on the chlorine dose rate, and then you divide by the hypochlorite solution. Finally, you will be able to get the required volume that you need to provide is 12.8 liter. So hypochlorite pumping rate is 12.8. The required volume divided by unit of day or hour. So you will get hypochlorite pumping rate is 0.53 liter per hour. Okay. Okay. Second example is on the breakpoint chlorination. Referring to figure, if a dosage of 1.8 milligram per liter is administered, determine the amount of free chlorine residuals that results, the amount of combined residuals that results, and finally, the amount of combined ammonia chloramine residual that results. So this is the answer. Okay, from the figure, you know that for concentration of residual chlorine at a dosage of 1.8 milligram per liter, this is your dosage, 1.8 milligram per liter. So you know that the concentration of residual chlorine is 0.38 milligram per liter. Okay, so the breakpoint of the residual at the breakpoint at the residual is 0.2 milligram per liter. So therefore, free chlorine residual is 0.38. Your dosage minus 0.2, the meaning that the residual at breakpoint. So you will get 0.18 milligram per liter. Okay, and B, amount of combined residual. Okay, amount of combined residual at breakpoint, meaning that after you combine the residual, finally you will get this due to chlorine reducing compound, chloramine and chloroorganics. These are the formation. This is the highest amount that they will reach, and finally they go to breakpoint. So the concentration of residual chlorine at the free chlorine residual is only 0.18 milligram per liter, because you have already minus the dosage, using the formula that we have discussed just now. Amount of combined residual. So finally, at breakpoint, after the combined residual, you get 0.2 milligram per liter, at the breakpoint. Okay. Amount of combined ammonia chloramine. Combined ammonia chloramine. Finally, it will achieve this breakpoint, and there is no more ammonia chloramine. Maybe some of the chloramine has formed nitrogen gas. Finally, there is no more ammonia chloramine. So what you have here is only the presence of chloroorganic compounds, not destroyed. So the amount of combined ammonia chloramine is 0 here. Okay, maybe the chloramine has been used to produce nitrogen gas. Okay, I think that's all for disinfection and chlorination that you need to know for as your knowledge, and also for you to be able to design to complete the design of your water treatment plant. So I think many of you will have to use this unit for your water treatment plant. Any questions from you all students? Any questions that you don't understand? Because all of you need to use this. Almost all of you need to use this unit operation. The chlorine, not necessarily chlorine. I give you freedom to choose which type of disinfection process that you want to use for your water treatment. Okay, yeah, but I explain more on the chlorination because the advantage of this disinfection treatment is the best, for all these from the experience of water treatment operators. Okay, any question, student? Any question that you want to ask? I will upload the slide in your UKM folio. And again, to test your understanding, I think because this is only the material that I need to share with you, but I want to test your understanding based on more. I think I will give you more questions for your quiz, because when you when you answer the quiz, if you cannot do the quiz, then you will try to find the answer, and I will only give the answer to all these quizzes before your final exam later. Okay, but I want you to read the slide and also do the quiz. Okay, so tomorrow there will be quiz, or you want to have it like what we did for the previous 2 weeks before. We do it on Wednesday night. Which one do you prefer? Do you want it to have early in the morning tomorrow night, or you want to have it at on Wednesday night?
Wednesday night.
Wednesday night. So I will give you quiz on this material on this slide Wednesday night from 8 to 9 as usual. Yeah. Okay. Any question? No more question?
No, Prof.
Okay, so good. I hope that you understand the material. Actually, water treatment is not that difficult. The material is easy for you to understand, and you can also use the lecture for your treatment plan design that I asked you to do in the group. Okay. Okay. See you again next week. For next week is okay. We have another 2 weeks for lecture. We have the membrane and also the biological system that we use for polishing of water supply system. It's not like for the wastewater treatment. It's a lot of material for wastewater treatment if you talk about biological system, but for water treatment, it's just for polishing. Usually that you use this membrane, and then sometimes you combine with this moving bed bioreactor that I will share with you in the following week. Okay, see you again next week. Take care. Okay, Assalamualaikum and good afternoon. Okay, students.
Thank
Okay.
you.
Thank you, Prof.
Thank you, Prof.